Hello, and welcome back to day 7 of LeetCode Grind. Solf or go home. 30-minute solf or go home. Alright, let's see what we got today. Okay, problems. What's today? Oh, alien dictionary. Okay, cool. In an alien language, surprisingly, they use English lowercase letters, but possibly in a different order. The order of alphabet is some permutation of lowercase letters, okay? Given a sequence of words written in alien language, the order of the alphabet and the order of the alphabet return true if and only if the given words are sorted lexicographically in this alien language. Okay, cool. So input array is words hello and LeetCode. Order is some crazy string. True. As H comes before L in this language, then the sequence is sorted. What the hell is it? Oh, okay, that's what it means. So as long as the order that they give you is sorted in the American lexicographically correctly, then that means the sequence is sorted, right? Is that what it means?
Oh, so the original alphabet is A, B, C, D, E, F, G, blah, blah, right?
Yeah.
So that means A comes before B comes before C. So that's two.
Oh, so it's saying that H comes before L here and before A.
Right.
So that's why hello comes before LeetCode. But if it was ABC would come third in this array, not first. Right? Is that what it's saying? True. Is it true or not true?
So sorry, say again.
So if ABC was also in this array, it would go in last place, not first place.
Right.
Okay, cool. Okay. All right. I see this. Okay, so basically we want to preserve the ordering of their order. So in that case, I mean, technically it is an array of 26 letters max. So technically, if you're looping through it all the time, you're not really getting super crazy long time run times, right? But there might be a better way to do it instead of looping through it all the time to check to see what position. I mean, oh wait, no. What am I talking about? You can make a dictionary and store the letter and its rank. So like if I loop through this order H through Z, H is first index, L is second index, A is third index, and then after I have that dictionary, I go to the word. I'm only pulling the first letter of each word and checking it on its rank and making sure the next word behind it is not the rank behind it. So well, not the first letter. You start with the first letter. If they're both the same, then you gotta move to the next letter and then move to the next letter. Yeah.
Right.
Yeah. But then I think that works, right?
Okay. Then how do you know that it's in order?
How do you know what's in order? If the words are in order?
Yeah.
Yeah, as long as it's the word after your current word isn't a higher rank based on the order that is set.
Right. I think you have the right idea.
Yeah.
So basically, you compare every pair of them, right?
Yeah.
Every adjacent pair.
Yeah.
And then if they're all in order, then you know it's in order.
Yeah. So you kind of do a sliding window compare.
Not really. It's basically for each pair you check, and then if any of them is out of order, you know.
Then you just return false straight over. Okay, that's fine. All right. So just to build the dictionary first, for I in order, let's just call it this.
Okay. What happens when you run out of letters in one word?
Okay, so you say run out in one but not in the other. Is that your question?
Sure.
All right. I think if you have less words, but the fact that you ran out of letters means that they were both lexicographically exactly the same until that point. Which means when you run out, that means that's good because that should be sorted before the next one that has an extra letter.
No. So is the shorter word the one that ran out less or more than the one that still has stuff?
I think it's less. Is that not true?
Okay, that's right. That's right.
Okay, all right.
So, but that's not going to have a letter that you can look for the rank of.
Yeah, so basically, if it's empty, then you know it's good. So you can keep going. You don't have to. You don't have to keep checking.
Yeah.
Okay. So to build a dictionary for I in order, I equals the index. So we need to have an integer for this.
So
Actually,
this
no.
is
We can just do range len and do it like that.
so you can do enumerate also.
Wait, what happened? What you said?
So there's a function called enumerate
Oh,
in
okay.
Python,
How
which
it
gives
does
you the
this? I
index
never
and,
seen this before. What do I do?
just enumerate of order.
So, like, literally the keyword enumerate? Like that?
No, for index comma element and enumerate of
Index, comma, what?
element or character or whatever.
Oh, so you're declaring index and the element as variables in this, so you can access both. Is that what you're saying?
No. So enumerate gives you it's a join of the index and the array itself.
I'm not sure I'm following what you're saying.
Okay, then just print enumerate of
So,
order.
like that of order, like that? Is that what you're saying?
No, not of. With parentheses, you're calling a function of.
That's because you said enumerate of. I was like, what are you talking about? Okay.
You should not have a space after print.
That's just an object. You can't print that.
You should not have a space after print. Okay, then for elements in enumerate an element. No. Do the for loop and then print element.
So you're saying this and then print elements.
This is just to show you what enumerate does.
You saying like this?
Sure.
All right, okay, fine. All right, let's see what's up. Oh, so it returns a tuple. Is that what you say?
So that's why I'm saying for index comma character, accessing the tuple there.
Yeah, that's what I'm saying. That's what I was asking anyway. So when you did index comma element, it's these two vars are instantly set to the tuple pair, right?
Yes.
Oh, okay. So you have access to both of these while you're looping. Okay.
Mm-hmm.
So then you do dicts element equals index. And let's print the dict to make sure it properly built itself. Okay, that looks good. Okay. Then now we want to loop do the words. Okay, so while len while let's just do index equals 0. Words do word clone. Okay, wait. So word 1. I can define a helper to handle the returning part, right? Or actually no. If I check it, I can just return false at this point. So I don't need tabs.
So the moment it's out of order, you can return false.
Yeah. So yeah.
But if nothing is out of order, then you return true.
Yeah. Well, you return true at the end. At the end.
Right.
So while that's fine. So index. So you want to compare the current index with the index plus 1 word. So you're gonna do you're gonna grab the first 2 words, okay, and then you're gonna start comparing them. So all right, so I'll just declare word 1. Does it let you have numbers and vars here in Python? It's fine,
Yeah,
right?
it does.
Okay, so
Fine.
we're gonna do words index word 2 with words index plus 1. So this is while it's less. I should be index plus 1 is less than, because then I don't want to index out of bounds this shit. Okay. For I in word 1. Oh wait, let's just length compare first. If length is off. Wait, actually no. If length is off, doesn't necessarily guarantee the lexicon.
It doesn't matter.
Yeah. Okay. Yeah, it doesn't matter. Okay. So So I probably want to compare the one with the shorter length to the other one, so I don't index out of bound error. I think. Yeah, because I want to loop through the shorter one, but I guess I think that's good.
Yeah, that's fine.
Yeah. So for I in range len min word 1 word 2.
Other way. Min of len.
Min of what?
Min of len 1 and min of len 2. There's no length of a min.
Ooh, oh, yeah. Good catch. Good catch. Okay. All right. Yeah. So word.
Well, no, this is also still not right. You
Wait.
can only call it on one thing.
Wait. What do you mean? This is.
Len takes one argument.
Yeah. Okay. Yeah. You're right. You're right. Okay. So this bracket, and this bracket. Okay. I think that's fine, right? Yeah. Yeah. That's fine. That's fine. That's fine. I think we're good. Okay. Min is taking these two vars. Yeah. Okay. All right. All right. So if len word 1 I no, we want this word 1 I greater than this word 2 I, return false. Else index +1. Wait, no, we have to loop through the whole word. So not. Oh yeah, this is index. Oh no, else no, yeah, else you just keep going, and then it'll keep looking. So it will go to the next one, and it'll look at that index. So no, so we need the if. So we need to check to see if it's empty first. The empties. Okay, because okay, wait. If we're looping through the shorter one, so it's word versus. Like, let's just visualize a case because this is words. Okay, so if I do that, it will check the first. It's not greater, so it keeps going. Check. It will check all the way up to 4, and then it's still good. So, and then it will stop looping at this point. But then there's still letters here. So, but it doesn't know that. So I think I would need to have a check outside. Maybe no. I was thinking of I shouldn't pop the letters as I go because that's just extra run time for no reason. Okay, how about if at this point if they all came out and it still didn't return false, but the length of this word is greater than this one, then I can return false also. I think.
Oh wait, no. Okay. So, okay, let's say you have E versus like A, B. Right?
Okay. Sure. So A and A will compare, and it won't return false. And now you're done with the loop. So then, right when you exit the loop, you can do an if check, right? If word 2, len word 2 greater than len word 1, then you can also return false because the other case didn't catch it, right? If this didn't trigger, that means they're lexicographically equal completely. And because you exit,
where do you check equal? Where do you check equality?
Oh, you're just checking greater. Yeah, my bad. Okay, yeah, then this doesn't work. Okay, so how do I handle this then? Okay, so if it was never greater at all, you know it's sorted, but you don't know it's equal. Yeah, so that doesn't help. Okay.
Oh, no. So I think what you should do is check character.
Check the character if they're equal first.
Yeah.
Okay, so if word 1 I equals Oh, so wait,
Right, so, there,
I
so
think
there's three cases, right?
yeah. So if they're equal, you don't care. So you don't even need to check this case. If they're not
No, no, well,
equal, if you're
you check
not
the next digit.
no, if you're not equal, then you check this thing, this case, right?
What?
Wait.
No, so there's three cases for each digit. It's either equal, greater, or less.
Yeah.
And you know what to do if it's greater or less. You don't know what to do if it's equal.
If it's less, you just keep going.
No, why would you keep going? You already know what's sorted if it's less.
Yeah, but then you wouldn't return true there.
There's never going to be a case.
Oh, I guess you could just break then. Is that what you're saying? Break.
Right.
Yeah.
Right.
LF. 2, wait, 1, I. Okay, and then the last case is else, basically. That means they're equal. What do I do when they're equal? So when they're equal,
And you have to check the next digit.
Yeah, you just check next digit. So you don't do anything because it's gonna loop to the next index anyway. It's always looping to the next index because then if it didn't return false or it didn't break, it's gonna go to the next index. So this is a useless case. The only thing I'm worried about is when you finish looping, there's still more on that side. So okay. I think I can have a boolean. Same word equals false. If it exits this array, then it's same word equals true.
Not necessarily. Like, what if you have the last case, like apple and apple?
What do you mean? So you said app and apple, right?
Correct.
App and apple. So this would exit with 2 characters left here, and this side has
Correct.
Yeah. So that means at this point, if you exited, I claim same word to be true, and if same word is true, then you check the length of these 2 words. If this is greater than that, then you're in correct order. If it's not, then you're in bad order.
It's more same prefix, but it's not short.
Wait, what do you mean by more same prefix?
Not the same word. It's the same prefix because you.
Yeah. Okay, yeah. I just named it wrong. Okay. Yeah, same prefix. Okay, that means okay. So if you exited this, wait, no. So okay, so there's else. Same prefix is true, but then no. Wait. Hold on. I'm not done. Same prefix is true only if you did not. Only if you never hit the break. So. If you never hit the break, then it's true. Prefix. Okay, how do I account for this? Because if I'm looping through all of it, you don't know that you broke out of the array, or you don't know if it's, well, you know if it's false because you just returned false. You don't know if you broke out of the array. So maybe if I store an index, I will know if I broke out of the array.
You have to check if the current thing is true, right? So there's global true, which is the final return, but then there's local true, which is what happens when you break.
Well, if you break, you never set same prefix. It's still false. But then when am I setting it is the question, because if I'm setting it outside, then that doesn't help anything because I don't know if I broke out of the array or if
First of all, you don't even need same prefix if you already broke, right? Well, you should have a flag that.
So, you're saying I should have a flag that. Oh, so okay. I see what you mean. Okay, so instead of break, I mean I can still break. I can set same prefix to false here. Wait. There's no need to set to false because it defaults to false. Alright, instead of doing that, maybe I can do, get the index, and then, yeah, I mean, this should be relatively simple. Okay, so if I just do count, or whatever, let's call it min length, grab this part, and then instead of for I in range, I can just do a while. Wait, no, min length would get me the maximum number. Oh no, it's still a 4. Wait, why did I do that?
Okay, here's another thing you can do. You can find which one is the shortest one, and then see if the other one starts with that one.
Find the shortest one and see if the other one starts with what?
So
like if
so
check to see if this word is a subset of the other word?
No, in the beginning of the other word, not a subset.
So you're saying find the shortest, compare the first two characters? Isn't that what's happening already?
No, you don't. No. So if one word is a subset of the other one,
yeah, then you know.
No, then you know if it's in order or not, if the length is not the same.
Yeah.
But if it's not a subset of the other one, then you should do the for I and blah blah, right? Like what you're doing here.
Yeah. Okay, but the problem is if you do subset check, doesn't that take a bunch of runtime for free? I guess that's fine, right?
Yeah, but I mean, this is the method you've chosen.
No, I don't.
It's fine.
Okay,
no,
because it's like
you look at the constraints.
Oh, right. Because if you check subset, and then it's true.
Not subset. It literally starts with. So you take the longer one and you do.
Yeah.
With.
Yeah. Okay. But then so if that one like if you already get your case out of that, you don't have to execute this line of code. So I guess it's still the same runtime.
Right.
Okay. So max word equals. So you want the max len of this max doesn't give you the word, it just tells you which the max is. So I think you would have to do wait, how do you do this? So if app is 3, apple is 5, well, you clearly know apple's longer, but you don't in code, there's no way to grab it from that. How is this so confusing? Alright, so if it's apples 3,
you expect word 1 and word 2 to be in order, so that already lets you test that, right? So you should just see if word 2 starts with word 1, right?
But if it doesn't, then
then you should do the check.
Oh, because if it doesn't, you can just false it. Wait. Word 2 is in word 1. Is that what you said? No, it should be word 1 in word 2.
Word 2 starts with word 1. That means, and they're not the same length. Then you're good. Actually, if any point word 2 starts with word 1, you're good.
Only if the length is the same, right? No, only if the length is greater. Even. Because if it's
if you have app comma apple, right? Then apple starts with app, but this is the correct order because app runs out of letters.
Oh, right, yeah, that is correct order. Okay.
Apple starts with apple as well, so if you have apple, then
you're
word 2
also
still
good.
Starts with word.
Okay,
So you should check word 2 starts with word 1.
Yeah, but is there like Python syntax, or I would just have to loop through it?
Oh, just Python syntax.
what is it called?
So if word two starts with word one, you can break.
Is it dot starts
Else you
with
should do,
like that?
yeah.
So that's the actual method.
I think it's lowercase with, but sure.
Okay. If word two starts with word one, that means
You should continue
you continue. Yeah. So
or break. You should
so no. So it's if it's
you have to do
not
the thing.
not words with one two, then you execute this line of code. Yeah. So you don't need this.
Okay.
So yeah. So basically, if it doesn't start with it, then you gotta check this stuff, and then
Right.
if you broke out, you're good.
No, so it doesn't matter.
Yeah.
Like basically, at any point, if you never return false, then it's true.
Yeah.
By default.
That's fine. That's fine. Okay. And then okay. So basically, if you never return false and you're out of this loop, then you just increment index, and then it will move to the next two words. Okay. I think that's good. So if I do words, so word one would be word two would be words, and then word two starts with word one, so it's already good. It's gonna skip that. It's gonna index plus one. It's gonna come into here index. So index plus one is one. So it's gonna look into it one. So index one plus one is two. Two is not less than length of words, so it's gonna exit and it's just gonna return true. So that's fine. Alright. Okay, I think that's good. If I try app and apple, that's easy. So I shouldn't do that. I should try like ABC def. Well, clearly word two doesn't start with word one here. So it's gonna loop through it. The min, there's no, wait, what happens when you min two is the same? It just returns the same thing, right? It's fine. Okay. Then it checks if A is greater than D. So in this dictionary, I believe, in this case, A is not greater than D, so it's good. So just keep going. And then if and A is less than D, so it's gonna break, so that's fine. And it's gonna increment index and it's gonna exit. Okay. Yeah, I think this is fine. Alright, let's grab this one. Oh wait, they don't like that. Gotta do this. Oh, I don't think I ever hit the timer. Oops. Completely forgot. I'm at like 28 minutes right now. Oh, okay. That's wrong. What's up? So, Apple.
How come app starts with apple?
It doesn't though.
Oh no, then you need else. You need else.
What do you mean? Because then, okay, so it says if this didn't happen. Oh, then you need to return true if it doesn't start with it, right? Yeah. Yeah, you gotta handle that case. Because if it didn't start with it, then it's bad. Wait, what?
What? Hang on. Go through that logic.
Okay, so it's apple and app. Okay, so app does not start with apple. So it should return false right here. Why is it returning true? What? Alright, let's print that shit. Word two that starts with word one.
No, because it's never less. So it always is equal.
What do you mean?
So it doesn't start with it because it's too short, right? And then
yeah, it doesn't. So that's false.
You never have the greater than. You never have the less than.
Oh, wait. So it doesn't start with it. So you're supposed to do this, right? Yeah. Then why did it end? Okay, so
Follow through.
Okay, so for I in range min length. Okay, so word one is apple, This is app. So the min length is 3, so it's gonna loop through 3. Okay, that's fine. Word 1 is apple. So A compared with A is good. It's not greater. It's also not less. So it's gonna keep going. P and P also skips both of these. Also P and P also skips both of these. Then it exits, but it never checked the LE. And then so it exited and you never checked the LE, but clearly apple is greater than app, but it doesn't know that, and it just kept going. So instead of this, you have to check if the length of word 2 is greater than, or if length of word 1 is greater than word 1, then you gotta return false. Is that the only case? Because in the other one, if it's the opposite way, Apple definitely has app. It's just app doesn't have Apple. So yeah, this is the only edge case that happens if they're both the same, because Apple encompasses app, but not the other way around. So yeah, this case will trigger only when they're the same, but the first word is longer. So I think that works. But it doesn't. It does not work. Why does that work? Oh, this one's false always. So it's triggering this. It's not gonna hit this LF. So okay, that's wrong logic clearly. But if I hit this stuff, I loop through it. It's all good. So so it's not an LF. It should be an if statement. Because if you went through this code and then wait, is that
Right,
true?
that means the prefix was equal. If it never returned false.
Yeah, prefix is equal. If you never return false, prefix is equal. And then the only way that this line would hit is if this word is longer than this word, because if it's the opposite way around and the prefix is equal, then it should have exited right here, because word 2 does start with word 1, and you wouldn't have to run this code. So this code only runs if it's the opposite way around, I think. Okay, that looks good. So I try it with like bot coin. Okay, that looks good. Alright, what other cases is this one? Try this one. Oh wait, why did I keep copying the whole thing? Alright, that looks good too. I think we're okay. Oh, wrong answer. Nice. I guess I missed something. Alright, what's wrong with this? Expected true for this. Okay. So KUVP. Q does not. Okay, so word 2 is Q, does not encompass this. So it would skip this. Wait, does not start with, it would go into this, never mind. Okay, and it would only loop through once. So it would check Q and K. In this dictionary, K is earlier than Q. So it would have checked K versus Q, and it would have said, yeah, K is before Q.
Right, so you do the break instead of setting it to true.
Oh, you mean, wait. Oh, it's because I broke and then I checked the length. Oh, okay. So I didn't handle that case where it broke,
So when
but
you
then
break,
this,
the internal thing is true.
yeah, this internal thing is true, but not the global true. So I still needed that boolean.
Right.
Okay, so same prefix is false. So it should be if same prefix and this. So I don't need to set it to true per se. It's just if I break, it would check this. But this, if this is hard coded to false, when does this flip? When does it flip? When does it return? When is same prefix set to true? It is true when the word is in word. So if it would be the else case of this, right?
Not quite.
I think.
Oh, yeah, 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 yeah. That's, that's not sufficient.
Um. Okay, so I'm breaking when it's less than, which means I'm good to go. So which means I should not trigger the bottom part at all. So it shouldn't just be same prefix. It should just be like
If you have some kind of like in order is true or something.
it's like, yeah, it's order good order, good move. So if I'm here, that means good move is true. And then I just put in 2 lines. So what am I doing?
But you can break at that point.
And then break, yeah. And then I don't need this, I don't think. So it's not good move. Then I do this, because good move is true. If it's not true, it won't trigger this. And then, do I need to set an else? If not, word 2 starts with word 1. So in this case, Q definitely doesn't start with this. So it's just gonna run this. But in the case, in the other case where it does start, like if it's apple and app, where it starts with it, it's just gonna exit this, and that's, and good move was false. So it's gonna say true and the length of word, and it's gonna trigger this, and we don't want to trigger this. So I think I do need that else here to handle that. Because if it does contain it, then we don't want to do this code. But actually, no, this is len word 1 greater than word 2. So that doesn't happen unless it's apple app instead. If it's app apple, it won't trigger because it contains it, and it's gonna skip it. Yeah, wait, I don't think I need that. Alright, let's try this. Okay, let me try apple again. What was the apple one? It's this one. Okay, we're still good on that part. Let's just flip it around. Make sure. Okay, that looks good. Okay, I think we're fine now. Alright, cool.
Okay. So I think in general, there's this I don't know if you've heard of this thing called a comparator
Yeah, comparator. Yeah.
or comparator. I don't know what you
Yep. Yep.
call it.
Yeah. Yeah. Yeah.
But
I use that from time to time.
you can use that kind of logic to build some way to sort this. So like you can do this in one line if you want, it, uh, with some Python magic. But it's good you work through the logic. But I think you might want to be a little bit more organized. And I think the general way to do this is to make a custom comparator that tells you when something is less than, equal, or greater.
Yeah. So typically the comparators we build in Java are pretty, I guess, like a lot simpler logic than this. I'm not sure. Like, I've not. I definitely haven't built a comparator in Python before.
No, I mean it's just a function that says is this less, greater, or less, right?
Yeah, but then like you still have to feed the logic into it to
Yeah,
sort
that's
of
fine.
return
That's fine.
stuff.
But you basically did the logic yourself, so it's a lot cleaner if you go that way.
Wait, are you saying if you declare a comparator and then you just check the word less than or greater and then you
Correct.
just pass the pattern?
I'll put it on the Discord.
If you just pass the pattern, it just does it by itself.
Mm-hmm.
Are you serious? Wait. So
Yeah,
wait, how
I'll
does
see
it
if
work?
I should.
So you're making like a comparator's method, right? And then you're just passing a b, which is the two words, right? But and then does it take a third variable as the pattern or something like that?
Yeah, let me put it on Discord.
Yes, I will take a look. And before I take a look, I will stop recording because I failed and I'm going home.